Welcome back, student, to part 5 of section 11.10. Today we will discuss a very important topic which will be kind of a revision of everything we did so far. It's about the applications of Maclaurin series and Tyler series. Now, the first thing we can see in number 10, if we are thinking of this integral x squared sine x squared, this is a little bit difficult integral to be found. I think we need to use integration by part in a certain way. So what we will do is we will use series to evaluate this integral. This is very difficult one. Even when integration by part, we will get stuck at some point. So there is no way, no method that we have seen so far can solve for me such an integral. And the only idea I have is to use the Maclaurin series. So I will write the series for the sine and then I will do the integration. So let's see how this will go. First of all, x squared will wait here. And here I have to write the series for the sine. Now, you can choose between closed form or expanded form. It's up to you. My advice, and I will say it clearly now, do at home both. In every problem you solve in the book, practice the both ways. Solve it one time as expanded form, the other time as closed form. Please do it by yourself to get confident and to understand the difference between expanded form and closed form. In this example, I will just take a random choice. I will choose the expanded form. So I need to write the Maclaurin series for the sine. If you remember, the sine would be the one that has the odd power of x. So it will be something minus something power 3 over 3 factorial plus something power 5 over 5 factorial minus something power 7 over 7 factorial and so on dx. Now, what do I mean by something? It should be an x, but here my input is not x, it's x squared. So everything here must be x squared. So this would be x squared, x squared, x squared, x squared. Now, the next step is you do x squared. Now you expand this one. Let me just do it in a different color just to mention. This is x squared. This will be x power 6. Now 3 factorial is already 6. Plus x power 10 over 5 factorial is 120. Minus x power 14. 7 factorial is 5040. Or you can just keep them as factorial. Doesn't really matter here. Those are just numbers. dx. Now the next step, take the x squared inside. So I think everything will be the same. We just have to multiply everything by x squared. So we get x4, x8 over 6, x12 over 120, x16 over 5040 and so on. The last step and the easiest one is to do the integration. And we all know how to do the integration. So let me just do it a different color, just to mention that we are doing the integration up here. x4, it will be x power 5 over 5 minus x8, it will be x9 divided by 9 times 6, it will be 63 plus x13 over, we have to multiply 120 by 13, whatever this number is. Just do it and simplify it here. Minus x17 over 17 times 5040 and so on. At the end, remember we have the constant because we do the integration. That's how we do the integration using the Maclaurin series. Nothing more, nothing less. Everything should be the same. You can, of course, do the same question, but instead of having the expanded form, you just have to use the summation. And that's what we get. Now, the second question is very much similar to the previous one, but here he said he wants to find the approximation of this one up to 4 decimal places. So now this will get me back into approximation of series. So let me do this question now, and let's see how we can solve it. In this question, what I will do, I will use the sigma notation. You can use the expanded one, but we just used it before, so let's do something else. Now the sigma, it should be summation from 0 to infinity. Now remember, the sign is alternating, so it is -1 to the n, and then it has odd power over odd power over odd factorial. Now what should I write here as x squared, because my question is with x squared. Now I think we can simplify everything. So this is integral from 0 to 1, summation from n0 to infinity, -1 to the n. And then here we have x to the power of 4n plus 2 divided by 2n plus 1 factorial dx. Now, of course, the summation and the integral can be exchanged. Everything with n can go outside. They have nothing to do with x. And then we have this integral, which is from 0 to 1, x 4n plus 2 dx. Now this integral can be found easily here. Now what is this integral? As the following. It is x 4n plus 3 over 4n plus 3 from 0 to 1. Now we have to substitute, I think, 1 and 0. If we substitute 0, there will be nothing, so we substitute just 1. And if we did 1, it will be -1 to the n over 2n plus 1 factorial 4n plus 3. Now this is the summation. Now if we want to find the answer within 4 decimal places, this means the error is 0.1234, so those are the 4 decimal places, and then maybe something like 1. So what we need to do, if you remember what we did in finding the error in the alternating series, we write the absolute value, the one without -1, less than or equal the error, and then we try to check which one will give me the error. So this will be 1 over 2n plus 1 plus 1 factorial 4n plus 1 plus 3 less than 0.00001. Now, as I said before, my advice to you, try to guess the number of n. So check n equal to 1. Do we get the answer less than 0.001? And then check n2, and then check n3, and 4, and so on. So I will leave it for you as an exercise to practice. And please write for me in the comments what will be your n. And what will be the summation after you use this n. If n is 5, you need to substitute the first 5 terms. So you will substitute n equals 0, n equal 1, n equal 2, n equal 3, n equal 4, and then using your calculator, find for me the approximation. This is a very nice question because it has many ideas. We use Maclaurin series, we use integration, and we use the approximation of alternating series. Next type of applications for the Maclaurin series is to use it with the limit. Of course, with the limit, we have the powerful tool of L'Hopital, but in some cases, we will ask you to use the Taylor or Maclaurin series in order to find out the limits. And usually in the limit, we will use the expanded form. You can use the closed form, but the expanded form will be much easier using in the limit. So let me use the expanded form here. X goes to 0. I have x squared, I have x, I have a minus. And then here we have to write the expanded form for the len 1 plus x. Now, this is something I think we all remember it. It will start with an x. Okay. And then it will alternate x squared over 2. There is no factorial. It's similar to the e, but without factorial. And it's alternate. Maybe 5 terms is enough. Maybe even 4 terms enough. We just write 5 terms here. The next step, we just need to take the negative inside. So we get x, and then we have minus x plus x squared over 2 minus x3 over 3 plus x4 over 4 minus x5 over 5 and so on over x squared. Now, x minus x get cancelled. Okay. And then we need to take x squared as common factor. So we take x squared as common factor. What will be left is half minus x over 3 plus x squared over 4 minus x3 over 5 and so on over x squared. Cancel, cancel. What we have is this one here. Half minus x over 3 plus x squared over 4 x3 over 5 and so on. The last step, substitute the 0 and the final answer is 1 over 2. Now, please, can you check that we get the same answer if we use L'Hopital? That's the big question here. So what happens if we use L'Hopital? Do we get 1 over 2? Check that one and please write for me in the comments in this video. Another easy limit here. I think I'm leaving this one for you. It's all the same steps. Everything is the same. So please solve it using this using the Maclaurin series. Okay. Solve this using the Maclaurin series. And write for me the answer in the comments. Okay. Now, look at this question here. In this question, I don't need to find the whole Maclaurin series. All what I need to find is the first 3 non-zero terms. So we need to find the first 3 non-zero terms. So what we will do is the following here. F of x equal. First, I will write the terms of the e minus x. Now, if you remember e minus x, it's a plus something square over 2 factorial plus something cube over 3 factorial. Maybe I will need the next term, but for now I'm not sure. Let me just write the first term. And then from the cosine, I think cosine is straightforward. It is 1 minus x squared over 2 factorial plus x4 over 4 factorial minus x6 over 6 factorial and so on. Now, what should I write here is negative x squared, negative x squared, negative x squared. And then we just multiply each one by each other. So the first with the first, first with the second, first with the third, and first with the fourth. Now, first with the first, this is 1. First with the second, x squared over 2 factorial, x4 over 4 factorial, x6 over 6 factorial. Next one will be negative x squared with everything. So let me just do it in a different color so that we don't mess things up. So it will be negative x squared, and then it will be plus x4 over 2 factorial, and then negative x6 over 4 factorial, and then plus x8 over 6 factorial. Now this one finished, this one is finished. Maybe we will need the next one, I'm not sure, but let's see how many terms will survive up here. So if we just write the final one, let me do it in a different color as well. The 1 is 1. Now the x squared, here we have half, so we have 3 over 2x squared. X power 4, they will survive. So it will be x power 4. This is 2. This is 24. It will be 13 over 24. And those are the first 3 terms. Do I need the next one? Maybe. But he said find the first terms. So 1, 2, 3. 3 terms. And that's exactly what we have. So we have a couple of more questions, but for now I'll stop this video. Thank you for watching. Please watch the next videos.